Just a second. Okay, so do you have your own question or shall I use my own for that?
There is a question in that assignment, ma'am.
Of linear combination?
Yeah, of linear dependence and independence.
Okay, all right.
Question 3.
Question 3. Okay, I'll check that. Okay, give me a moment, I'm just checking. Okay, we'll do that. Let us understand first linear combination
Okay.
and then linearly dependent and independent.
Okay. Ma'am, what's inner product?
Yeah, we'll do further. Okay, after that, we'll do.
Okay.
Linear combination of vectors. Let us understand that. Can you see the whiteboard?
Yes, I can, ma'am.
Okay. So linear combination of vectors. Let R be a linear combination of vectors v1, v2, and v3 up to so on, such that R can be expressed as alpha 1 into v1 plus alpha 2 into v2 plus alpha 3 into v2 3 and up to so on. And here R is linear combination of vectors v1, v2, v3 and up to so on, and where alpha 1, alpha 2 and alpha 1, alpha 2, alpha 3 and up to so on are scalars. Okay, and these alpha 1, alpha 2 and alpha 3 and up to so on belongs to field set of scalars. Okay, so combination of vector, scalar and their sum is known as linear combination. Got it? You got it?
Combination of scalars and vector is called a linear
Yes.
combination.
Yes, exactly. Now got it? Yeah.
Yes, ma'am.
Okay. All right.
Can we do an example?
Sure. 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 Will do. So, for example, uh, let v1 is equal to having a vector 0, 1, 2, and v2 another one vector 1, 0, minus 1, and v3 is equal to 1, 0, 0. Now let us form the linear combination along with alpha 1, alpha 2, alpha 3, and you can take any values of them, or otherwise you can express only in terms of alpha 1, alpha 2 up to alpha 3. So let us form the linear combination, which is R is equal to alpha 1 v1 plus alpha 2 v2 plus alpha 3, because we have only three vectors, so obviously we'll use them and take
Okay.
scalar up to 3 only. So now let us form R, this linear combination. So linear combination of vectors v1, v2 and v3 along with alpha 1, alpha 2 and alpha 3. This can be expressed as, and R is equal to, we can use the values of v1, v2 and v3. So let us put alpha 1 and vector v1, that is 0, 0, 1, 2 plus alpha 2 1, 0, minus 1 plus alpha 3 1, 0, 0 we have. Okay. Now we need
Okay.
to multiply them. Just a second. Okay. R can be expressed as,
Plus alpha 2 plus alpha 3.
Leo. Yeah.
Is that
Yes.
right,
Are you
ma'am?
saying something? Are you saying something?
Is it 0 plus alpha 2 plus alpha 3, then alpha 1 plus 0 plus 0, then 2
Yes.
alpha 1
Yes.
minus alpha.
Yes. We can express this as 0 into alpha 1 plus alpha 2 plus alpha 3. And next alpha 1 plus 0 alpha 2 plus 0 alpha 3. Similarly, we have a combination of 2 alpha 1 minus alpha 2 and plus 0 alpha 3. And finally, we can express this linear combination and take all the values including 0 as a coefficient, then we can express them as, this linear combination can be expressed like alpha 2 plus alpha 3 and alpha 1 and 2 alpha 1 minus alpha 2. So this is a linear combination of the given.
Okay.
So now you got this topic or want some
Got it, ma'am.
more example? Okay. Shall we do now linearly independent and independent?
Yes.
Okay. Just a second. Linearly independent vectors. If linear combination of if v1, v2, v3 and up to vn are vectors and alpha 1, alpha 2, alpha 3 and up to alpha n are scalars, then linear combination of then linear combination of vectors along with scalars if expressed as like alpha 1 v1 alpha 2 v2 plus alpha 3 v3 and plus up to alpha in v into vn is equal to 0 and if alpha 1 is equal to alpha 2 is equal to alpha 3 and up to alpha is equal to alpha n must be 0, only then this linear combination 0, then we can say vectors are linearly independent. Okay, if
Okay.
linear combination of these scalars and vector is result of this is equal to 0, while all of these scalars are is equal to 0, then we can say vectors are linearly independent. If any one of them means any one of them these scalars is non-zero and still they form this result is equal to 0, then we can say vectors are linearly dependent. Are you getting this point?
Kind of, ma'am.
Pardon?
Not entirely. Maybe with an example.
Okay, sure, we'll do an example to understand as well. Just a second, I'm just opening an example related to this. Okay, let's see. Example, if we have v1 is a vector 1 1 3 3, v2 minus 1 1 minus 1 3, and v3 2 596. And let us form the linear combination along with alpha 1, alpha 2, alpha 3. Let us make it. So alpha 1, 1, 1, 3, 3 plus alpha 2, 2 minus 1, 1, minus 1, 3 and sorry plus alpha 3 into V3 2596 is equal to 0. Means this right side will take is equal to 0. Okay, let's do.